Hello, welcome to this third video in the series for volume. It's the second video where we look at examples. The goal will be to go through two more examples. All right. It's cross sections, volume by cross sections, Calc 2. My name is Nakia, and I'm here to hopefully help you through this journey, explain some calculus to you. All right, you ready? First up, example 3. It's called a solid has a circular base. And the base has a radius of 4. And you slice perpendicular to the x-axis. And this time you have a square. Our job, find the volume of the solid that comes out of that. Here's a picture that I found that will be a good look at what the 3D shape looks like. So it's a circle, sliced perpendicular to the x-axis. We'll get these squares coming out. Small squares, the smaller the x is, and it gets larger and larger. When x is 0, actually, you get the biggest possible square. And then it goes back down again as you go out to radius is a 4. So there's a picture of the base. What I like to do is draw the picture of the base and make a slice. Now, when your slice is perpendicular to the x-axis, then your integral is done in x. Okay, so there's our slice, and that I always like to label my slice S. It represents the side length of whatever shape you have. In this case, it's a square. Okay. Well, you know about the area of a square. It's just going to be S squared. There's no mystery to that formula. You don't have to pull that off your cheat sheet. Okay. So how long is that slice? It changes, right? Depending on where you're at. When X is equal to 0, that slice is 8. 4 up and 4 down. But as x increases, it goes down. When x goes to the negative, it goes down as well. And so this distance off of the x-axis is called y. Okay? What we're going to need is an equation. What's the equation for the circle? Centered at the origin. They said nothing about it being centered at the origin, so it's just going to help us to have it centered at the origin. Okay? What's the equation of the circle? Centered at the origin with a radius of 4. X squared plus y squared equals 16. Okay, and the integral's done in terms of x, so we can take this equation and solve it for x. We'll solve it for y and have a formula in x. Okay. All right, so y squared is 16 minus x squared. Take a square root, and we get plus or minus the square root of 16 minus x squared. You see, the top half is the plus, and the bottom half is the minus. It's not a function itself, broken into these two parts. Each part is its own separate function, and we need both. Honestly, when you're trying to find the slice, I want you to think of coming off of whatever axis you're slicing perpendicular to and going and finding an upper minus a lower. Now, that little small slice there is up to root y, root of 16 minus x squared. You go up y, but you also go down y. Okay, and so it's, and because of the symmetry of this, whatever you're going up is the same as that you're going down. So we have y and y. So that slice length will always be double y, 2 times y. So what you're going to do? This thing has to be done in terms of x. Rip out the y formula. Rip out the y and put in the formula for it, which is root 16 minus x squared. That's what S is. Not exactly root 16 minus x squared. Remember now, it's double that. Okay? What's your formula? Just take S and square it. That'll be the area of the square. Okay, so let's square this. S squared is 4. Don't forget to square the 2. Times, you get to lose the radical. That's great. 16 minus x squared. This is cross-section volume. Okay, so what we're doing is developing this formula, and I mean, like 75% of the question is just in the setup of the development of the formula, because the rest of it is just calculus, integrating that formula. Thankfully, most of these end up with some nice integration, but we've learned a bunch of integration techniques, so we're going to find out that some of these integration techniques might be involved, but not on this one though. And what does x change from? The smallest x is -4, and the largest x is 4. Make sure you can figure out the bounds too. Okay? All right, once again, I won't go through the integration. I'm confident that you can integrate that. This is not what this is about. I'm focusing on the setup. Okay? So pause the video, work out the integral, and we're just going to find out if you need to look at the steps. Here they are. Final answer should be 1024 over 3. Okay? All right, great. That was example 3. Let's do another example. Example 4, where we have the base of the solid described by some functions, the region in between these curves, and then cross sections coming perpendicular to the x-axis, this time a different shape, isosceles triangles, where the height is always 6. Step 1 in the process is to get a good drawing. Y equals root x, got to know what that looks like. Y equals x over 2, you got to know what that looks like. So root x is a parabola that's turned on its side, the 1/2 of it. And y equals x over 2 is just a line coming from the origin because it's like mx plus b with m being a half. Make sure you can, if you mess up the base region, automatically the rest of the problem falls like dominoes. And so you got to make sure you get a good drawing of the region, got to know your curves, and then you got to make sure that you can finish the problem out from there. We're talking about isosceles triangles where the height is always 6 as you go from left to right. Okay. And we got to figure out, this is a nice computer drawing, right? But when you draw it, you won't have this accuracy. I can look at this and eyeball and say, oh, I go from 0 to 4, definitely. I want you, though, to know that you're going to have to use algebra to be able to find that. But you'll be able to do it. So you make your slice and you call it S, and that S is the non-matching leg of the triangle. You got these two legs that match, right? Isosceles, 2 legs that match. And then there's a third side. And the third side is S. All right, so let's take this picture, turn it. This is S. This is the bottom there. That's the base. S is the base. And the formula for any area of any triangle is 1/2 base times height. So the area of this triangle is going to be 1/2 of S times 6. The 6 is not changing. It's going to stay at 6. The height will always be 6. That's a nice formula. That's not bad at all. 1/2 base times height is 3S. But here's the issue. We need this in terms of x. When you slice perpendicular to the x-axis, your formula for area will be in terms of x, not s. So we need a formula that'll tell me that distance s based on the x value. Okay? And just think upper minus lower, okay? If it's sliced perpendicular to x, or right minus left if it's sliced perpendicular to y. That's all it is. There's an upper function, root x. There's a lower function, x over 2. The difference between them is what s is. So you subtract root x minus x over 2. That's what s is. Rip out s, put in root x minus x over 2. You got your formula. Now you just need to know the bounds and you just integrate. And so it's about these curves being equal to each other. You don't have a nice computer drawing like I do here, so you're going to have to do it yourself. Square both sides for sure. Why not? Okay, multiply by 4. Get rid of fractions, please, whenever you can. Clear them out. And now it's looking better. Now you know what to do. Set it equal to 0. You got a quadratic. You factor it, but it's nice. You can factor out. It's not a complicated factoring question. Each one of them has to separately be equal to 0 for the product to be equal to 0. So either x is 0 or x is 4. And those are your bounds. Spend a lot of time making sure that you got the right setup. Okay, the focus is on the setup. The integration is secondary. But we have it. It's 0 to 4. And pull the 3 out. Root x minus 1/2 of x. Okay, polynomial integration, or a nice little power rule in reverse integration. I'm sure you can do it. Not integration by parts, not partial fractions, not trig substitution. Simple integration that you could have done in the previous calculus class. Pause it. Pause the video if you can, and work it out. And then if you need to, look at these steps. But the answer is 4. All right, right at the 10-minute mark, let's go ahead and stop. Thank you for watching. That'll be it for our cross-section examples. Next time, in the next video, we're going to jump into the disc method and the washer method. All right. Thank you for watching. My name is Nakia, remember, and I'm here to help you. Please ask any questions if you have them. Yeah, like and subscribe, as my daughter tells me to say. Bye-bye.